Hi there, welcome back. Today we're going to learn about addressing modes in 6502 assembly and how we can leverage them to deal with data and print things to the screen in a smarter way. So first let's take a look at this example from a previous episode. We had defined character by character, the characters we needed to print apple, and then we were one by one loading them into the accumulator and then getting them to the memory, to the video memory, the right addresses in video memory, so they would be printed out. So this is of course clunky, and there is a better way of doing that. And here is the example. I'm gonna briefly walk you through this, but there's some new instructions that we have to unpack here. So first notice that here at line 16, we have an instruction called hex, which is basically going to populate a certain address in memory with whatever content we define using hexadecimal, in this case characters, right? But basically any hexadecimal data. So the characters C1, D0, D0, CC, and C5, they spell out apple. This is a comment, right? So this is really where the apple string is being put in a certain address in memory. And by the way, this is the reason why we have this thing at the bottom of the program, because if we were to put it here at the start, we would have this character sitting in this memory position, and this simply does not play well when we try to execute the program. We try to execute these bytes as if they were instructions, and of course this is not going to work out. So we have to put our data at the bottom. So let's see what this program does. By the way, this description is of course incorrect. We are actually printing apple to the screen once more, but in a smart way, smarter. So out of our monitor functions, we are needing only the console output function. And line 6, our program starts, and we are loading the X register with the value 0. And here we are doing a funny thing. We are loading the accumulator with something new. So what's going on here is that we are loading the accumulator with a base address, and that's the address where our string apple is, right? That we defined. Here's the data label. So this is pointing to this memory address. But we are adding to this base address, right? The base address is the start of the apple string. We are loading, we are adding the contents of the X register. And we know the contents of the X register at this moment are 0. So we are actually starting at the base address data. So we're gonna start with the character A. And this addressing mode, where you combine an address with the contents of a register, it's called indexed mode. We're going to visit, using the assembly lines book, we're going to visit all the addressing modes that exist. And because they allow us to do tricks like this one that we are looking here. So we basically, when we start the loop, because X is 0, we are just starting with the character C1 with A. Then we print it to the screen. Then we increment X, right? Basically, we want to go to the next character. Then we check if the X register contains 5, right? Because this is gonna happen after 5 characters are gonna be here. And if that's not the case, we go back to the start of the loop, and then X is incremented. Right now it's 1, so it's going to be data plus 1, so it gets the D0 character. we go and loop again, and then we take the second p, the next d0, and we do this until we reach 5. That's the end condition. And then we just print the carriage return character. Is going to cause our line to end, right? So it's an end of line character, and we print that one, and it's over. So let's see this thing in operation. So I will assemble it, and I will execute the program. Yes, so we, as expected, printed apple. That said, it's good that we look at the book and we understand a bit more about the different addressing modes. And here they are. So we already know many of them. We might not know their names, and now we will know both what they are and their names. So there is the immediate addressing mode, and that means a constant. So that's the pound sign plus the dollar, and then we just provide a constant, for instance, a character. That's how we printed in our first example, how we printed out the characters, right? We passed them using the immediate addressing mode. So the absolute addressing mode, we give as parameter one memory address, and then we load, for instance, if it's a load accumulator instruction, we are loading the accumulator with whatever the contents of this memory address is. If we are addressing something that's on the 0 page, then we can simply use a shorter address. In some commands and some instructions, you don't need to provide anything as a parameter because it's obvious already from the instruction itself. So in this case, for instance, this is a transfer accumulator to Y register instruction. So you don't need to say anything other than that, right? You're saying take whatever is in the accumulator register and put inside the Y register, and that's it. Then we have the relative addressing mode, and the relative addressing mode, it's basically a number of bytes up or down from where we are, from where this instruction is. Then we have the indexed mode, which we just discussed, and that's you give an address, and then you give a register that's going to be used as an offset to that address. So it's going to be added to that address. And with loop structures, we can basically operate on data. And then we have a variation that's called the indirect indexed. And it means that instead of providing directly a memory address, we provide an address that contains the memory address that we care about. So yeah, that sounds complicated. So let's look at an example. For instance, you say LDA $80 between parentheses, and that's the trick to the indirect part, and then the Y register. The Y register, let's say it contains 4. And the base address 80 contains 0. It's called base address because this indirect mode, we actually need 2 bytes. So to give us the memory address, so we use bytes 80 and 81. And the bytes 80 and 81, they contain 0 and 02. In this case, they are inverted to compose the memory address. The order of the bytes is inverted, and the reason for that is 6502 is a little endian processor, which means that the least significant bytes come first. But yeah, the idea is if you express an address using 2 bytes, the last or the second byte is the first part of the address, and the byte that comes first is the latter part of the address. So this is how you express address 200. So this $80 pointed to location 80, and location 80 contained the value 200. So this thing between parentheses is evaluated to 200. And then on top of 200, we sum the 4 that were in the Y register. So this is going to evaluate as 204 if address $80 contains 200 and the Y register contains 04. And there's also the indexed indirect. And in this case, both the memory address and the contents of X are indirect. So we instead of taking instead of adding the contents of the X register, we go to the memory address pointed to by the X register. We extract the value that's sitting in this memory address, and then we sum with the first argument. So you see, it's basically, when you find this parenthesis, it's just saying, go to this memory location, fetch the content, and that's going to be a pointer to another memory location, and that's what I want to use, the content of the second memory location. So that's why it's called an indirect mode. So this may sound complicated, but in practice it is not. So when we see this example here, for instance, it's pretty understandable, and I'm pretty sure that the others are going to be as well. Okay, so here we have an example, and this one is going to use the indirect indexed mode. Now, instead of trying to print characters, we are clearing the screen, and we do that by taking all the screen video memory addresses, and those are addresses starting at hexadecimal 400 through 800, and we basically fill it all with blanks. And the way we do that is we start by setting a certain memory address, and that's going to be the base memory address 6. So this is in the 0 page, and you already know that we need 2 bytes for a memory address. So we're gonna use memory addresses 6 and 7, but the base one is 6. So what we do here is, okay, we defined our pointer, right? And that's equals 6, that's the base memory address. And we do some initialization here. And here we are basically putting on the base address 6, we are putting 0. And in the next byte, that's memory address 7, we are putting 4. So because of the little endianness, we have to put the 0 and then the 4, and then, but this is interpreted the opposite as we discussed, so that will translate to 400. So what we are doing in this whole entry thing is we are setting the memory addresses 6 and 7 to 400 hexadecimal. So here we start by loading the accumulator with the blank space. And then we start our loop by taking this blank space and putting in the base the address that's pointed to by pointer, and that's 400, right? Because we put 400 here. So we are basically saying take this blank and put on 400 plus y, and y we know to be 0. And for this reason, it's going to be in the $400 address. So when we do this, we are basically clearing the first video memory character. Then we increase the value of the Y register. And you can see that this is important because when we go through this loop, we are adding to 400, the base address, we are adding the Y register contents. So if we keep incrementing, basically we are doing 401, 402, 403, 405, 404, 405, and so on. Here we check if we have already hit the maximum value that we can have, which means it would be 0, right? We would exhausted the values that you can do with a byte. And while we haven't done that, we just keep doing this. So when we reach the end and we come here, what we are doing is we are incrementing the byte, the most significant byte, the one that's here. So when we do this, we are flipping this 4 to be a 5, and then it's going to be 500 rather than 400. Then we also load this value into the accumulator. We check if we have already hit 800, because $800 hexadecimal 800, as you might recall, that's the top address of a video memory. So when we reach that one, we are good. So unless we have reached 800, we go back to the start. So you see that what we are doing here, it's using the contents of the base address to set if we are clearing the 400 or the 500 or the 600 or the 700 range, and then we are using the increment of the Y register to then do 0, 1, 2, 3. So it's almost like we have two nested loops here that allow us to both change the column and the row. So let's see this. You see this is a nice use of the indirect indexed addressing mode. So let's run this code and see if it does what we expect it to do. So first we assemble it. Then we execute it. Yeah, and it cleared the screen, all right, as we expected.